Today we constantly hear about declarative as the right technology to provision and manage resources. So in this video, let's find out about imperative, declarative, and what that has to do with me eating pizza. So in this video, I really want to explore imperative versus declarative. And what got me thinking about this is I started to watch the new Picard program. It got me thinking about Star Trek, and I watched a bunch of the old Next Generation movies like First Contact and Insurrection. And Picard is the ultimate in declarative technology. Picard just has a desired end state. That's declarative. I want to be at warp factor 10. Make it so number 1. Poor number 1 has to go and work out how to do that. I want to be at this location. I want that fixed in 10 minutes, not 20. He declares what the end state should be. So that's declarative. And it got me thinking about, well, what are some other good analogies? And I'm a creature of habit. Every Friday, I go and have pizza and then ice cream. And I can think about, imagine for a second that kind of there's my house, there's my pizza restaurant that I go to every single Friday. And imagine my wife is driving. So I could think about, if it was imperative, I have to give the explicit instructions on how to perform the actual task we're trying to do. So I would have to say, hey, we come out the house, we turn right. We go across the first intersection, then we turn left. Then we go across another intersection, and then we turn left. So that's imperative. From this location, if I follow those set of instructions, I'll end up at a certain place, which happens to be the pizza restaurant. Now the challenge with this, imagine there was road work. Well, I would have to handle that. I would have to change my instructions. Imagine I started off in a different state. Imagine at a friend's house, imagine it was at the gas station. So if I just blindly followed my set of instructions that I give to get to the pizza restaurant, you could say, well here, okay, well I come out and I turn right, I go across the intersection, then I turn left, then I go across the intersection, I go across the intersection, and then I turn left. And my car ends up in a lake, and definitely not getting any pizza. So if I'm imperative, I have to handle changes in maybe my starting state. I have to handle changes in things that may occur along the way, roadworks, whatever that might be. If this was declarative, I would simply say to my wife, hey, my desired location is the pizza restaurant. That's all I have to say. I'm not worried about where we're starting from. I'm not worried about if there was road work. I want to be at the pizza restaurant. Make it so number 1. At which point I definitely wouldn't get any pizza. But let's just imagine that was the state. If there was road work, if I started from somewhere else, it doesn't matter. Because I've simply stated my desired end state, the technology, in this case my wife driving, would make sure we take the right directions, any redirect, whatever, to end up at the pizza restaurant. Another great benefit of the declarative is, well, am I in the right state? I can very easily tell. My desired end state was to be at the pizza restaurant. Am I sitting in front of a pizza restaurant? Yes, that's accurate. If I try to say, well, am I at the right end state for imperative, that's pretty hard to do. How do I check? Well, did I turn right? Did I go straight? Did I go left? Did I go straight, and then left? That's much harder to check. So from a compliance perspective, am I at my desired end state? With declarative, that's very easy to do. Is the reality matching what I wanted? If it was imperative, it would be very hard to do. So imperative, I have to explicitly state every single step to get to kind of my goal. Declarative, I just state my end desired reality, and then something else takes care of making that so. Now, if I was at the pizza restaurant, I sit down. I sit down at the table, and there's a glass of water on the table, there's bread on the table, and then the waitress, Caroline, who looks after us every single week, asks the desired end state. Again, declarative. I don't tell them how to cook a pizza. It's not imperative. I don't say, hey, get some dough, roll it out 12 inches in diameter, apply 2 scoops of sauce, and then lay cheese, and then onion, and put it in the oven for 5 minutes. I don't do any of that. I declare that, hey, my end state, I would like to have a cheese pizza. I would like it to have sort of tomato sauce. I would like a cheese pizza. There'll be some cheese on that pizza, some onions, lightly cooked, no basil, don't like green stuff. So I desire my end state, I'm declaring it. So they come away, and when it comes back I get my pizza. And again, from a compliance perspective, I can easily check. I know what my end state was. Is that what is in front of me? When the manager comes along maybe to check, hey, did I get what I ordered? Well, he knows I ordered a cheese pizza with onions, lightly cooked. He can easily see. If he had to try and go through, well, he asked for this dough to be rolled out 12 inches and 2 scoops of sauce and a handful of cheese, it would be very hard to check. He'd be picking through my pizza, and then I probably wouldn't want to eat it. So I declared my desired state for my pizza. Now I also wanted water. And again, my desired end state through my declaration is water. I'd like a full glass of water. So as I start drinking the water, I think I drink a little bit. When the waitress walks past, she can see it's no longer at my desired state. So she can actually go and add more water to it. So if my glass of water gets out of compliance, well, that's easy to check because I know the desired state. She knows, hey, the desired state is a full glass of water. She can rectify if things have changed. So I think about compliance. When I use a declarative technology, because I'm specifying the end state, it's not just, hey, it makes it easy for me to describe, it makes it easy from a compliance perspective. Am I meeting the requirement? And again, the manager can easily walk past, check desired state. Now there was bread and water already on the table. My declarative statement was cheese pizza and water. The water was already there, no changes were required. The pizza wasn't there, they had to go and make the pizza. So they only have to do things if the desired end state is not the current state. They didn't go and get a different glass of water, it was there already. So my desired state is really incremental. Hey, I want a cheese pizza and water. Well, the water and bread's already there. What's the delta? The delta is the pizza. So they go and add the pizza. Now, I never asked for the bread, but because my intention is kind of incremental, the bread can stay there. Now, imagine I was on a super strict diet. I only wanted the stuff I asked for. I would be giving a complete description. So it would be a complete deployment of my desired state. So I would say, hey, I want cheese pizza and water, nothing else. Maybe I'd be tempted to go and eat it. So if I described a complete end state, then anything that was on my table that I had not described, they would remove. So in this case, I described a pizza and water, I hadn't described the bread. So this was a complete rather than incremental, they would go and remove the bread from my table. So again, I'm just trying to stress the point that when I use declarative technologies, there's different ways I can apply it. Hey, incremental, the things I describe, make sure they're there. But if there's other things, they can stay as they are if I don't describe them in my desired intent. But if I deploy in a complete mode, I'm saying this is exactly what it should look like, then it will actually go and remove things that I have not described. So now I want to go through a couple of demos. And I'm going to make this very, very easy. What we're going to do is we're going to create a storage account in Azure. And then inside that storage account, we're just going to create an empty container. That's it. Nothing more. And what we're going to do is kind of contrast an imperative approach using PowerShell, then declarative using an Azure ARM template and Terraform. And we'll mess around with this a little bit. If we think about my road directions, my steps work. If I always start from my house and I follow those steps, and if there's no road work or traffic congestion, I'm always going to get there. But what about if we start at a different point? It doesn't work. I would have to add extra steps to say, well, hey, if I'm in this location, if this has already been done, let's start from here. If my journey was interrupted, it's going to mess with that flow. So what we're going to try doing is when we look at our storage account, we'll try maybe, well, what if we already have the storage account, but it doesn't have the container? What about if I want to change the type of storage account? Maybe it's originally created as a locally redundant storage account, but then maybe I want to go to a globally redundant storage account. How do I handle that with imperative versus declarative? Hopefully try and drive all these home. So let's jump over to some demos. For our 3 demonstrations, I have 3 different resource groups. One for my ARM template deployment, one for the PowerShell deployment, and one for the Terraform deployment. Now currently, these are all empty. There's nothing in any of these resource groups. And we're going to basically go and add all of that stuff. So we'll start off with PowerShell. So if I jump over to my Visual Studio Code, now the resource group already exists. I've already logged in. Let's just define this variable quickly for my base path. And what we'll actually do for the PowerShell to make it a little bit easier to follow, I've already created kind of a final script, but we won't go there yet. I'll just create a new file. So we'll say just in progress .ps1. So we were taking this approach. I want to go and create a storage account and create a container. Now we'll say there's some variables. We have a name for our storage account. We have a resource group we're going to use. What is the SKU? So it's locally redundant. Where am I creating it? And then where I'll store the storage account object. So I have all these variables. So this is going to be imperative, remember. I have to tell it what to do. Now the first thing I have to do is create it. So I'll just say, hey, okay. I'm going to use the new AZ storage account, use all our variables. And then once that's happened, well, I just need to get a storage context so I can actually perform actions against my brand new storage account that I just created. And then I'll just go ahead and create the container. So very easy. There's my few steps. And I'm telling it exactly what to do. Hey, you have to go ahead and create the storage account. You have to get a storage context. Then you have to create the container. So if I kind of ran these just one line at a time, just you can kind of see all this happening. So again, make sure we've defined the variables. Then we'll run create the storage account. And we'll see that happening. If we jump over to the PowerShell resource group, what we'll see is once this completes, we'll see the storage account created. Then once it's created, we'll create the context to it, and then just quickly create a container called images. So that's completed. We'll get the context using my currently connected account. And then let's go ahead and create the container. So let's jump over and look. If I hit refresh, there's my storage account. And inside my storage account, if I go to my blob and look at my containers, well, there's my container. It did what I wanted. Fantastic. Now I'm going to delete this. Imagine I was starting at a slightly different position. And again, notice our type is locally redundant. So now let's check. Now I'm just going to make sure the context is null at the start. So we'll go through and we'll run our variables. Now we'll create our storage account, which fails. It already exists. That's okay. We're going to get a storage context. Well, that fails because this variable was never populated with a new storage account, which means creating the container is going to fail as well. So if I'm using imperative, I'm going to have to do a bunch of work. So for example, I'll have to first check, well, does it already exist? So let's try and check, see if I can get the storage account. And then only if the storage account is actually null, so we'll add in some code here. So if it's null, then okay, I'll create the storage account. So that should fix that problem. Okay. And then it will be able to go through and we'll get the storage context because it would have set it to the variable if it already existed. And it should be able to carry on. So now I've written extra code. It's imperative. I have to tell it exactly what to do. Okay, so let's check. Does it exist? Was it null? Well, that wouldn't have run because it's not null. But now it can get storage context. And now I can actually create the container. Okay, so there was actually work I had to do, but it was possible. Well, now suppose I want to change it to GRS. I changed the variable. Can I just rerun this? Of course not. But also my code has no ability to handle changing the type. I would have to write code to do that. So in this case, if it's null, well, I create it. If it's not null, well, then I'll have to add in a whole bunch of code, check it's the right type. So it already exists. Does the SKU name match my desired SKU? If it doesn't, well, then set the SKU to the new type. So I've changed this now to GRS. Now I would check, well, does it exist? Well, it's going to find it. Now I'm saying, well, I've got a whole if else. It's going to say here it already exists. I'm going to change the type. So if I refresh, go to my account, now it's GRS. And now I can get the storage context. It would carry on. You get the idea. I would do the same checking for the container. But for imperative, I have to do a whole lot of work. And kind of the neater version of that script when I'm cutting and pasting from is here. This is where I kind of go through, I do those checks. So imperative. Yes, I can achieve my result. I have to handle every scenario. If things exist, if they're the wrong type, there's a huge amount of work I have to do. And even with this, from a compliance perspective, how would I check this is right? It would be very hard to automate and look at the script and then look at what is there and say, well, is it matching? There'd be a huge amount of work to do that. So let's jump over to an ARM template. So here, if I open up my ARM folder, I have a parameters file that tells me the storage account name, the type, and the container I want to create. And then I actually have the ARM template itself that takes in those parameters and then has two resources. It has the storage account, and then within that, it's actually going to go ahead and create a container from blob services. So I'm stating my desired end state and then asking it to kind of just make it so. I'm not telling it how to do it. I'm just saying this is my desired end state. So if I go and look at its resource group, we can see it's currently empty. So here I'm just defining my base path, and then I'll run a basic deployment of that template. So I'll execute, Again, I'm just defining my desired end state. I want a storage account and a container within it. That's all I'm saying. So this runs, and once this completes, I should have that desired end state. Very simple. So I'll go and look. If I refresh, again, this takes a little while to catch up, but I'll have my storage account, and it will have that container within it. Just keep hitting refresh for a second. And here we go. And within that storage account, well, it's the right type, LRS. And there's my container. So let's break this. So we delete the container. Let's go back to our template. So obviously we expect this to break. So let's just try and run it again, see what error we get. And then we can work out what do we need to do to change it, to fix it. So we'll execute it. Let's wait and see for the error. Well, it finished. I didn't get an error. Let's go and look. There's my storage account. Container. There's no containers yet. Oh, there it is, refresh. So it just worked because it's declarative. I'm just saying my desired end state. It's its job to work out what a storage account exists, but the container doesn't. Likewise, let's say I want it to be GRS. So I'm going to override the storage account type. I could also do this by changing the parameter file, but for right now we'll just do it on the command line. So we're running exactly the same template, the same parameters, overriding just one parameter, which is the type. So let's run this one. The only change is my desired state now is that it should be GRS instead of LRS, and it's finished. I've not changed anything in the template. If we go up, I'm just going to look at our storage account, and we refresh. Now it's GRS. That's the power of the declarative technology. And you get the idea at this point. I don't have to worry about anything happening behind the scenes, how I have to handle errors, how I have to handle if something exists already. I don't care what it does. Make it so number one. This is what I want. I'm describing the desired end state. I'm declaring this is what I want. It's its job to make it so. Now, I could do other things. I could change the name of the storage account. So this time I'm overriding the storage account name. And if I deploy it again, let's see what happens. Now it should have a v2 in the storage account name. If we go back to our resource group and hit refresh, again, it takes a little while to catch up. Let's go and look at our script. So it's still running, it's doing that creation. So that completed. We jump back over again, hit refresh. Again, it's still catching up. It seems to take about 30 seconds. And there it is. But the old one's still there. Why is that? What did I describe? I described elements that had to match my desired state. But essentially at this point, the old one has become the bread on the table. I didn't describe it, but my desire is incremental. So the new storage account has to match my desire, but anything still on the table, i.e. still in my resource group, is left alone. I could change this. If I specified a mode complete, now I'm saying this is all I want on my table. This is all that's allowed to be in the resource group. It makes me prompt because now it will actually delete things that are not described in my template. If this is not my desired end state, but it was there already, that's not okay. My desired end state is only these things in the resource group. Anything else will be destroyed. So once this completes, we'll actually see I still have my v2. It didn't have to create it. It was there already. But my original one will actually now get deleted. So if we go and refresh, and again, it's going to take a while to catch up. Once this completes, we'll actually see it's gone. So that has completed now. If we jump over, hit refresh, the other one's gone. It's matching exactly my desired intent. Now to finish this, let's think about the Terraform option. So over here, I have a Terraform template, my main. I also do have variables. And here I'm just specifying the default type for replication, so LRS. But if I go back to my template, with Terraform, you can see I'm using a piece of data. So I'm actually getting an existing resource group. So I'm getting an Azure RM resource group and the name of the resource group I want to write to. So that's getting an existing object. And then, well, I want to create an Azure RM storage account. Then I want to create an Azure RM storage container. These are the two things I want to do. And once again, if we jump over, if I look at my Terraform, it's empty. Now with Terraform, I'm actually going to jump over to the folder. We perform an initialization. It's going to go ahead and get all the modules that it might require. Now, I have an extra step. I have something called a plan. Now, when I run this plan, what it's doing is it's looking at the current state, then it's looking at my desired state, and it will actually show me the difference between them. This gives me an idea of, well, what's going to happen if I actually apply this new desired state. So it's going to go through, it's going to look at what I've described, look at what's there, and show me the differences. So you can see it's going through all of this, refreshing all the states. And then it's got a whole bunch of information, but it's showing me, hey, these are the things that it will do. So you can see it's going to create. It's going to create the storage account with a bunch of attributes. It's going to create a container. So it's going to show me my plan would be 2 to add, none to change, none to destroy. So now I'll actually apply that. So I'm going to auto approve, so it's not going to prompt me to hit a key to say accept. So now what it's actually going is applying those changes. And again, it's going to take a while to catch up. But essentially it's doing the same thing. I've described my desired end state. I'm not telling it how to do it. I'm just saying, hey, I want a storage account in this resource group, in this name of this type. I want a container within it. That's all I have to do. I'm not telling it how to do it. Terraform is another declarative technology. And while we wait, one of the reasons we might use Terraform is, well, no, a number of reasons. One, it's a lot less verbose. It's actually easier to read than ARM templates for many people. But I think the biggest one would be ARM is specific to Azure. If I'm also deploying to other clouds, if I'm deploying to on-premises, the benefit of Terraform is they have providers for pretty much all of the major clouds, the on-premises virtualization technology, etc. So I'm going to be able to use one syntax. It will be different providers, but one syntax across many different clouds, many different environments. So I could be deploying to Hyper-V and VMware and Azure and AWS, all with Terraform. So that completed. Once again, probably have to wait a few seconds for this to actually catch up, but hopefully you get the idea by now. It's going to catch up. There it is. I'm going to have my container in there. And there, I could delete it. It will fix it. So let's just do that. We'll delete the container again. We're going to kind of merge two steps with one. I'm going to rerun the execution, but I'm going to change it now. So my variable is the replication type is now GRS. So my desired end state is no longer LRS, it's GRS. So let's run this plan. So it's going to tell us what it would do. Again, it's not going to change anything. It's just going to tell me what it would have to do. So what we expect is, well, remember, I deleted the container, but the storage account is the wrong type. So I'm expecting one addition and now one change. So it's going through, it's checking what it believes should be the state and what is the actual reality. So if I actually go and look, one to add, one to change. And it will actually show me everything it will have to do. So it would tell me, well, the container is going to be created, but it's going to say, hey, look, storage account will be updated in place. And it even shows me, hey, look, account replication type is going to go LRS to GRS. So now I can run this. And it's going to go and, as you'd expect, it's going to change the type, it's going to create the container. The key point here, declarative technologies. I just define my end state. It will make it so no matter what the current state, I can change resources, I can create new ones. I don't have to worry about it. I don't have to tell it to convert. I just say my end state. The reason we separate the variables from the actual main template is so then I can change control my main template. I can move it between environments. I can move it between instances, never having to change the template. Only the variable file would change. That's very important for change control. And not only can I deploy using these declarative technologies, I can use compliance. I can audit. I can say, is it matching the template? I can prove for audits that I'm in compliance because it matches that state. That is amazingly powerful, saying I really can't do with an imperative technology very well. And that's really why we like these declarative technologies. Hey, great, I have these templates that I can change control. I can move from dev to UAT to production without ever changing the template. I can deploy the same template to 50 different instances just by having different variable files. I can easily check, is it matching the end state for compliance, for audit reasons? I can easily change my config if I needed to. So it really gives me a lot of capability that with imperative, I just don't get. To just kind of finish this off, hey, look, it's back. And my type has changed to GRS. I didn't change anything in my template ever. If things existed, if I wanted to change things, there's lots of clever stuff happening behind the scenes that smarter people than I have created, but I don't care. The magic is I state my desired end state. I'm declaring what I want. I want my cheese pizza. I want to be at my pizza restaurant. Someone else, number one, make it so. So I hope that was useful. If it is, please give this video a like, please subscribe and share. And I look forward to seeing you on the next video. Take care.